We are present to witness a transformative shift in water purification.
This research addresses the solutions of heavy metal pollutions in water by utilizing natural wastes in a sustainable approach. We are from Kesatuan Bangsa Yogyakarta. I am Artha.
And I'm Sandrica, having developed an absorption capsule based on filtration system using silica from rice husk and cellulose from cassava peels.
Let's see how science can turn waste into solutions. The world is currently facing major challenges in meeting the demand for clean water. As the populations continue to grow, the demand for clean water increases, while its availability declines due to environmental pollutions. Consequently, communities tend to rely on natural water sources such as wells, rainwater, and rivers as alternatives.
In Indonesia, many water sources, including major rivers, suffer from pollution due to industrial and domestic waste. One example is the Gajahwong River in Yogyakarta, which, based on research by Sinta Deborah, contain lead ions at concentration of 0.1616 mg per liter, which is more than 5 times the safe limit set by the Government Regulation of Yogyakarta Special Region number 20 years 2008, which is 0.03 mg per liter. Meanwhile, lead poses severe health risks to both human and aquatic life.
To address this issue, our research focuses on utilizing rice husk and cassava peel as base materials for developing heavy metal absorbing filters, with the primary goal of effectively and sustainably reducing lead concentration in contaminated water.
The selection of material is based on the increasing consumption of cassava and rice-based food, which generate large amount of cassava peels and rice husk waste. These waste materials have high potential as heavy metal absorbent due to their chemical composition.
Rice husk contains a significant amount of silica ranging from 16 to 18%. According to Purwaningsih, silica possesses silanol and siloxane functional groups that facilitate interaction with metal ions through adsorptions and ion exchange. Additionally, silica exhibits high mechanical and thermal stability and can be chemically modified to enhance its adsorption capacity.
Cassava peels contains up to 80–85% cellulose by total weight, making them a potential absorbent material. Cellulose is polysaccharides with hydroxyl and carboxyl functional groups that interact with heavy metal ions through ions exchange and complexations. The high surface area and porosity of cassava peels further enhance the absorption efficiency of heavy metals such as lead.
So, how did we create and test aqua tests to reduce the amount of lead in Gajahwong River?
Purified silica is obtained through a series of chemical processes, beginning with immersion in 1.5% of natrium hydroxide solution to dissolve silica into sodium silicate, following the reactions.
The resulting solution is then filtered to separate undissolved solid residues. Subsequently, silica precipitation is carried out using hydrochloric acid, yielding white silica gel based on the reaction. The gel is then dried and characterized using X-ray diffraction (XRD) to confirm its purity. Based on research by Ridawati, silica characterization is conducted using XRD analysis at 2 theta angle. According to the XRD diffractogram, the observed peak with a 20° until 30° range confirm the presence of silica. The diffraction pattern of the silica sample exhibit a upward peak at 24.32°.
The cellulose extractions process is conducted through the following stages. High purity of cellulose is obtained through delignifications and bleaching, with functional group verification via FTIR analysis. Firstly, cassava peels are dried at 100°C and refined using a blender and a sieve. Then, immersion in 15% of natrium hydroxide solutions. Natrium hydroxide dissolve lignin and hemicellulose, leaving a more purified cellulose structure.
Bleaching with 30% of hydrogen peroxide. This process oxidizes color pigment and lignin residues, further purifying the cellulose.
Cellulose characterizations via FTIR. The primary functional group of cellulose are identified by the presence of OH, CH, and glycosidic CO bond in the material. The cellulose content is indicated by multiple peaks observed in the FTIR spectrum analysis. Based on our FTIR analysis, the presence of cellulose is demonstrated by the characteristic adsorption peaks. It can be seen that the presence of cellulose is indicated by the presence of OH functional group at these peaks, CO functional group at these peaks, and CH functional group at these peaks. The FTIR spectrum shows a diversity of absorption peaks indicating the presence of various functional groups in the sample. However, the main functional group that characterize cellulose have been identified. Once the raw material has been obtained, the water purification capsule is formulated with varying ratios of silica and cellulose in 3 different variables to determine the most effective compositions.
The developed capsules are tested using a standard solution testing procedure. Involved, each filter capsule is immersed in the referred water sample, and the dissolution time is measured, lasting for approximately 6 hours. The lead concentration before and after filtration is analyzed using atomic absorption spectroscopy.
The test results demonstrate that the silica and cellulose-based filter can reduce lead concentration within 6 hours.
The finding of this study confirmed that the combination of silica from rice husk and salts from cassava peel exhibit high effectiveness in absorbing lead ion from contaminated water. This capsule feature offers an efficient, cost-effective, and environmentally friendly alternative solution for wastewater treatment.
Thus, this innovation represents a tangible step forward supporting clean water conservation and sustainable waste management.
Thank you. We hope our research can be beneficial because no water, no future.
So choose the best solution!